logistics. So we have the AP coming, our AP, not this week, not next week, not the next week, but the next Tuesday. But hold on, we have a whole week of APs going on in between. How many of you guys have another AP you're taking besides calculus? Exactly. So those of you whose hands aren't up, you'll be with me the whole time. Those of you guys whose hands are up, sometimes you'll be missing this class. Does that make sense? If we look at the calendar, which we will not do today because we're trying to get through packets 9 and 10 questions, but when we look at the calendar, probably tomorrow or Friday, we need to figure out our forever final date when everyone's going to be here. Now, the good thing is you guys have gotten back your large forever quizzes from after spring break, and you can see the mistakes you've made, but some of you need to. It's okay, Zach. You can study. Poor Zach's up here like slapping himself. Okay, so then coming back. It'll be all right. It'll be all right. Okay, we need to start studying our forevers again. We need to start studying our forevers again, yeah? So some of you, that could be quoting. Some of you, that could be writing. Some of you, that could be just looking at the slides online, right? But forever final, it is going to be worth 25 points in your final exam category like it was first semester. Okay? So forever final, some of you need to be working on by the AP. Corrections on your mock exams that you on Friday. Finish, or you guys have review 11 today, review 12 tomorrow. That's our final review. Mock AP you'll get back, we'll work on. So corrections on the mock AP is going to be another assignment that's due. Your when you see you think. And I just said we had 2.5 weeks about, right? But one of those weeks, some of you are going to be shuttling back and forth in APs. Does that make sense? So we do have some time in a good, because you guys have grad night a day and then the AP. But anyway, just coming out. So there are things that come in. Remember, I did want to show you really quickly. I keep on forgetting to show you guys. I have loaded an additional optional number 3 bonus full-length exam in your folder. Remember these ones, there are evens that you can do for bonus in these packets. And for some of you, that's a good thing. But for some of you, leave those behind. Be working on practice exams for bonus. Remember, the practice exams are worth double the evens in the packet. And I know you're like, well, they should be worth triple. I can't just randomly give out like 10 percentage points on tests every practice exam. But I can give out what I'm doing now, which is the 4 points. And if you do all the evens, and there's a lot of points that are available, remember, in your test quiz category. But in order to get the points for these bonus exams, you don't have to have them printed out. You could save the PDF and write on it like we did for the spring break practice exam. But I do need to see it attempted, not just letters, attempted, like work, whether it's printed out or whether it's on paper. I need to see it section and graded like we did for the spring break one. Does that make sense? And then if you show that to me before the actual AP, you'll get those bonus points. And that might help out with some of the lower points of this year. Let's go ahead and get into number 9 and 10. We went through logistics really quickly so that you guys could just see a whole little like, hey, this is what's left. Let's get through the rest of what we need to. All right, here we go. What? Oh, question. Yes, go ahead. Well, here's the sad thing. Our AP is on Tuesday. There are technically APs going through until Friday of that week. Then we have a weekend. Then we have Monday, seniors, Santa Barbara Day away. Juniors, you'll be hanging out. Oh, I'll have you guys watch like a numbers episode or something. That'll be fun. Juniors will be hanging out. We'll be back on Tuesday. We'll have Wednesday. Finals start Thursday. Kind of. We'll be finishing a movie. So we'll start a movie on, probably watch a movie between Tuesday, Wednesday, actually, depending. Some of you guys will have an AP when we start a movie. I'll try to fit in 2 movies. I usually do. That's tradition. Well, we have our AP on Tuesday. I love how we're wasting time on this. We have our AP on Tuesday. Our AP is Wednesday, Thursday, Friday. Thursday. I'm taking it, though. What Thursday is. Anybody know what Thursday is? Second week of finals? I think it's something like that. Oh, APLAC, maybe it's Wednesday? Okay, it's Wednesday. Okay, so Wednesday we'll probably just watch a numbers episode, so juniors you'll miss, well, it depends. Anyway, we'll probably start a movie Thursday, watch it Friday, then we'll come back, watch another movie Tuesday and Wednesday, and then somewhere in there I'm sure we'll get a little bumped, so then part of the finals day will be finishing a movie, part of the finals day will be writing letters to next year, part of finals day will be giving me feedback on the course, etc., and part of finals day will be me saying goodbye. There you go, the end. Anyway, it's not here yet. Oh my goodness, I didn't know I get emotional. Okay, coming back, here we go. I usually don't. I've been pretty good the last few years, at least in front of people. Okay, so I'm totally one of those, like, cry in the car on the way home. I'm one of those kind of people. Not in front of people. It depends. It depends on the timing. It has to be, like, the timing has to be right, otherwise. But as a teacher, like, I'm used to just, like, okay, let's just do it. It's not about fashion. Oh. All right, here we go. Motion packet. I'm not afraid of motions, just in some points. I mean, you guys can imagine, teachers can't just fall apart like every day in front of students, right? Like, you have to, because some students would totally take advantage of teachers actually, like, were totally real with them all the time. So anyway. But I'm pretty real with you guys. You guys feel it, right? All right. Here we go. Why are we talking about my emotions on the video? Anyway, go team. Video. Motion! Here we go. We've done nothing productive. Oh, you know what's so funny? I was reading this morning in Psalm 44. It's okay. Psalm 44. I was kind of reading like Psalm 42, 43, 44. And then I went to Lamentations 3. Oh, I quote that one a lot. I was going to read it this morning. I'll read it tomorrow. Anyway, and so I saw something about enemies shaking the head at, and I was like, bah! And then there were cross references for shaking the head, and it went to Job, and it was like, shaketh mine head. And I'm like, what? SMH is so funny. Anyway, it was in the Bible, guys, shaking of the head, but it was a bit more intense than just, because I was thinking of shaking my head, and then it just, yeah, if enemies are shaking their heads at you, it's not good. But moral of the story, why would you be shaking someone else's head? I'm so confused. You guys know SMH, right? Like shaking your... Never mind. Never mind. Because I was shaking my head at myself, and then it all came out. Anyway, God is good. That was not the main point of my Devo this morning. It was all about hoping in Christ. But anyway, coming back. So, what do we got? Multiple choice. Too much coffee or not enough? What do we got? Did you make that? What is that, Zach? That's cool. Huh?
Oh, no, we already did some of these.
That's okay. Anything? FRQs? Okay, sweet. We're on the motion packet. Number 9. Okay. Shh. I'm trying not to laugh. I'm sorry. I'm just not hiding anything right now. So, here we go. FRQ, number 1. Do you guys have any questions? Yes. E? Sure. Traveled. Attach it to a formula. Total distance traveled. I need absolute values of changes in position. If I don't have those, then velocity plugged into an integral. Right? So, who is this guy? Velocity. Well, first, why don't you just write down the formula? Total distance traveled with velocity is the integral from 0 to 8 of the absolute value of velocity. Now, hold on. They don't give me a function. I can't integrate anti-derive by hand, so who am I looking at? And how do I? Yeah, area, right? But pause. Normally, I would do the little rectangle and then a triangle, rectangle, triangle, triangle, rectangle, triangle, and do like the positives and then negatives and put them all together. But what am I not doing? Or what do I need to switch? Not negatives. They need to be switched to become positives. And so what you would do is go and count it all up. And have you guys already done any sort of, you did from 0 to 5, right? 0 to 5 is 6. So I already know that this whole area is 6. I just need to add this whole area, which would be, let's see, a rectangle, base of 1, height of 2, so that'd be 2. And then these two put together is another rectangle of 2, so 2 plus 2 is 4. So I can do 6 plus 4 is 10. Pause. Pause. Pause, 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 pause. Make sure when you're doing your math, wanted on any of your papers equals 10?
Well, I mean,
Would I have wanted on any of your FRQs the number 10? No. What would I have wanted? Someone read off to me the work they did in letter C for the integral from 0 to 5. Actually do. Get that 6 to make it 11. No. The work to get the integral. Like the areas. What areas did you get for this one? Okay, do you guys know what I'm talking about?
no, she's asking for all of the additions.
I'm asking for all the additions and subtractions. You guys know what I'm talking about? Okay, because what I'm saying is I didn't want you to have the number 11 for letter C. I didn't want you to have the number 10 for D. What I wanted you to do was to have written for letter C, for instance, what was the initial? Okay, so S of 5 is equal to S of 0, which was, so you were right, it was integration as net change, Charlotte, but when we had to do the integral from 0 to 5 of V of t dt, you should have stopped by doing, don't we have a little rectangle or square? Is that a square? We'd have 1 times 1, base times height. We would have the triangle, 1, 2, 3, 4, no, 3. Base of 3, height of 1, so 3 halves. Then we'd have the rectangle, 1, 2, 3, the height of 1. Then we would have 1/2, right? Well, here's how I did it. I did it with, I did that little guy, I did that little guy, that little guy, and that little guy. That's what I did. So that was a little square, that was a little rectangle, that was a little triangle of 1/2 base times height, and then that was a little triangle of 1/2 base times height. Does that make sense? Don't make that 11. Why? Why? Just stop. Now, if you need to check it with the answer in the answer key, that's fine. Put it on your calculator. Be like, look, I got it. Check. But don't write 11. Nobody wants 11. Because most of you wouldn't have gotten 11. You would have gotten 10 or 9 or 22 or something random. So why am I saying that? Because for letter D, which was your guys' question, what would be the answer? Your 1 times 1 plus 1/2 3 times 1 plus 3 times 1 plus 1/2 1 times 1. Okay, that was just getting from 0 to 5. And then go ahead and do 1/2. Remember, don't make it negative because it's absolute value. So 1/2 1 times 2 plus 1 times 2. There's a rectangle. You guys see what I'm doing? A triangle right there, a rectangle right there, another triangle. Plus 1/2 1 times. Don't you dare ever make a mistake. And if you can say I never make a mistake, then okay, but otherwise, no. No. Or you put a star by it, and if you have extra time, you go back and double, triple check that simple arithmetic that so many people mess up. Yeah. Okay, letter E was another question, right? Speeding up or slowing down. Pause. We have a forever card. Come on. We have a forever card. Speeding up or slowing down. Another way of saying it is speed increasing or decreasing, right? The signs of what need to agree? Velocity and acceleration. That's a forever card, right? So the signs of velocity and acceleration need to match, which means I need to plug in at 2, what is my velocity? And plug in at 2, what is my acceleration? Now, velocity, can't I just plug it into what I have? Now pause. Oh, that was just an accidental cough. V of 2, here's the struggle, guys. V of 2, here's the struggle. I need to come back to the question so I can show this to you. At V of 2, is there an obviously defined point that they have written out for you? No. So here's the struggle. At 2, if you were to be like, dun, 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 I need to have a number because I need to write down a number, that must be 1.5. Could you be right? You could be, but could you be wrong? Now, here's a dealio. This is a line. You technically could take the point 1, 1. You technically could take the point 3, 2. And you'd probably be right because they were pretty clear on how they showed those. On an actual AP, they would be, I think this is an actual, actually. They would be a little bit more clear about stating those points for you so you wouldn't have to guess about it, wouldn't have to approximate as much. How could you know for sure on this one it really is at 1.5? Isn't this a line? Couldn't I? Midpoint? Would it work for, I guess technically midpoint would, well, just be careful. Depending on the line, I would rather find the slope. So I'd rather say, hey, the slope is up 1 over 2. And so if the slope is up 1 over 2, then I would go ahead and go up a half and over 1. That's one way of thinking about it. Another way of thinking about it is you can always make a line. You can do y minus y1 equals m. So y2 minus y1 all over x2 minus x1. That's the point, but hold on. There have been AP FRQs where you had to find the value, and the struggle is you can't just eyeball it. They've given you a linear function. You can make a line, and since you can make a line, you can plug it in. So if you did have to, thank you, Sarah, for saying that, though. If you did have to find this point, you could. And then you would have 1/2 plus 1, y equals 1.5. Just a hint, I've seen these ones where it looks like 1.5, and the answer is really 1.4. And they mark you wrong on it. It'd be one of those, yeah, you can't just eyeball it. It's a linear function you can plug in. But here's the struggle. Did you actually have to plug in for this? Do I need the actual v value? I just need the sign. So look at the graph. Oops, that's not going to work. Look at the graph and say, is the y value, is the velocity value positive or negative? Positive because, look, it's 1 point something. Yeah. Booyah, I don't have to say what it is. All I need to say is what the sign is. Acceleration. I have to take the derivative. No, because look at the graph. How do I think of acceleration, which is v prime, by looking at the graph of v? Slope. And what's the slope at 2? Positive. The function velocity is increasing. Velocity is increasing. Acceleration is positive. Careful. Velocity is increasing, acceleration is positive. Two very different words. So guys, look at it. Velocity is positive, acceleration is positive, so therefore. Have the same signs at t equals 2. Now, how can you sound really smart right now? Steal their wording and be like, you said it, I can say it too. Don't you guys do that in like Black and other things also, like steal what they say for the thesis? Do that here, okay? Since v of t and a of t have the same signs at t equals 2, the particle, right? It's an object. Sorry, Lo siento, I didn't look at it. P.S. Read what you're doing. The object is speeding up at that. Okay, FRQ, done. FRQ number 3, wasn't there another one? Let me zoom out real quick and get rid of all of this blah, blah, blah. Oh, yeah. Hold on, guys.
But is it wrong at all to say, to make the statement first, like the object is speeding up, and then state why?
No, that's okay as long as you know. As long as you know, but no, that's totally fine. Because I do that sometimes. When do I do that? It might be more BC actually when I do that. But sometimes I state, because I already figured it out, and I just put like a comma, since, da 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 da. But you can also do since, da 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 da, and then, yeah. All right, FRQ number 3. You guys only had 2 odds, is that right? Okay. All right, any questions on this one? We have a velocity. This is a non-calculator problem. Okay, just walk me through the math. If I have velocity, how did you find acceleration? How did you find position? Integrate, pause, you're going to have a plus c. Plug in the clue for c. Good. Pause. When you go to integrate, what did you have to do with sine of 3t? U sub. U is 3t, du is what? Du is 3 dt, so dt is 1/3 in the answer, right? Good. Speeding up, slowing down, what are you testing? A of and V of. Do you need to actually give me numbers? Just give me signs, greater than or less than 0. If the signs are the same, speeding up. If the signs are opposite, slowing down. What ended up being the answer? Look, look, look. You don't have to. They didn't even. I think an AP teacher actually filled this out, so that might be why. But they didn't even. Just greater than or less than. It's all that they care about. Letter D. What is the velocity when A is 3? What would you have had to do for that? Yeah, set A equal to 3. Find T. Ooh, unit circle. Struggle. Then plug into velocity. That was a little random, the unit circle. It's a little too easy for a calc problem, but some of you guys get stuck on the unit circle one, so it was good practice. Any other questions on number 9? Yeah. Oh, that's what they were asking for. They were just asking for velocity. And they didn't give any units. So you could have stopped right. You're asking like when you could stop, right? Oh. Right here. That's what you need to solve, right? You have to ask yourself, when is set 3t equal to, you have to undo the cosine. To undo the cosine, you take cosine inverse of the other side. But then there are lots of values where cosine can equal 1. Cosine can equal 1 starting at 0, 2 pi, 4 pi, 6 pi. So there are lots of places. So 0, 2 pi, 4 pi. But careful, it's not t equals, it's 3t equals. So we'd have to divide by 3, divide by 3, divide by 3. And then in this problem, I think there was a time interval, right? Where were we looking? We were only looking for the one in between here and here, so only the second quadrant. So then when you got this value, that's not in the second quadrant. This one is. That's not in the second quadrant. So I'm only looking at 2 pi over 3. Then we just have to plug in. And guys, when we plug in, we're plugging into velocity. They want you to simplify the unit circle. That wouldn't be sufficient of just plugging in 2 pi over 3 and leaving it. I don't think. I should probably ask a friend about that, just in case. But I think you would need to solve that unit circle value. They almost always do. But you don't have to go to a decimal. No. This is a non-calculator problem. What the? Yeah, no, you should have stopped there. Okay. Did I answer them all? LTF number 9? Okay. Pass them up. LTF number 10. If we pass them up, it's just out of your way. LTF number 10. Pass up number 9. Get out number 10. I apologize if the order was a little weird. Number 10. Oh, sorry. Thank you.
Will the AP graders get mad at me if I
draw pictures
with colored pens on my answer?
I'm not sure if you're allowed to have colored pens, are you? Oh, thank you.
Like hide answers. I've written notes.
Thank you. Your sister wrote notes. She wrote like a whole story, I think, to him.
Yeah, but I want to make like a nice picture, you know, like make all my graphs neat like this. Like, what if I do this on the? Yeah, I want to see something neat looking.
Yeah, maybe. Just make sure that you're not starting to answer your Scantron with color pen. All right, here we go. Number 10. What questions do we have? We're going straight into number 10. That way we can answer questions. None so far. I don't know if that's good or bad. 3? Cool. Thanks, Caitlin. Hey, it's a graphing calculator one. Go team. Question. Do we need to double check there are no intersections in between that interval? No? We don't need to double check? What if there was an intersection? Absolute value takes a region and makes the area between positive. But if you were to have, for instance, let me just show you a quick example. Just quick example, I'm making this up. This is definitely not either of these two functions. If I was to do something like this, and I was to do the absolute value of, say, f between A to B. Like, let's say they gave me AB, and there was an intersection in between. And I was to do the absolute value of f minus g. Here's the struggle. You would get the absolute 0 is 0. Because you would do you do f minus g and get a positive area. You do, let's pretend that this was symmetric. Sorry, I meant to make it kind of like even and symmetric so that they're the same thing. This f minus g would be a positive. This f minus g would be a negative. They would cancel out, and then you would do absolute value. Does that make sense? If there's an intersection, if you do the absolute value of the, sorry, I didn't write the integrals. If you do the absolute value of the integrals. Oh, why is Charlotte telling me to put it on the inside? Because I did them individually, but why should they go on the inside? How would that make things better? What do we do if we have absolute value on the inside? If we were solving it by hand, I know this one we just plug into our calculator, but let's make sure the by hand work would work. You check, yeah, handling absolute value and integration, you check to see if there are any zeros. When would any zeros of this occur? When f equals g, right? Oh, so then if you put an absolute value on the inside, you're going to find the intersection? And then split it up and do them separately? Yes. So therefore, if it is a calculator problem, if you were doing it by hand, you would have to find that intersection no matter what, if there is one. But if it's a calculator problem, you don't even have to worry about it because, good job, Charlotte. You don't even have to worry about it because as long as you put the absolute value on the inside, which we can definitely do. I have no idea what's back here on the screen, so let me just clear everything out. Oh, there is nothing. Okay. You guys know the shortcut for integral, right? Second window, or sorry, alpha window? Number 4. Then you can do your 0 to pi, and as long as you put the absolute value on the inside, you'll be good to go. Where's absolute value? Good. There's your absolute value. Then does it really matter who you put in where? Nope. So you can do your e to the, just make sure you're in radian mode. To be honest, I don't actually remember if I had to change for pre-cal or something. But I have e to the sine of x minus 2 dx, and there we go. Dun 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 dun. Yes, the reason why we have to put absolute value, I mean, we could graph these two functions and we could see exactly how they intersect, etc. But the absolute value on the inside is a fail-safe when you do f minus g. Handling absolute value on the inside of an integral, we have to split up at the zeros, if there are any. And the zeros would be when f minus g is 0 or when f equals g. So putting the absolute value on the inside accounts for what if they were to intersect. So at one point, maybe g should be minus f, and at another point, f should be minus g to make it all proper. Because what if top-bottom switch? We'd have to do that all by hand if we didn't put the absolute value. Yeah. If we just did it outside the actual integral, we'd say, hey, just do all the work and then make it positive. The problem is that doesn't account for if there's like a switching of the top-bottom, so that's why we need it on the inside. And if it is on the inside and we're doing it by hand, we cannot pull it out until we step where again? Yeah, good. Any other questions on multiple choice for number 10?
Number 8.
Oh, okay, we can peek at even. Ooh, this one's great. Was this the one, Sean, you were looking at? The ellipse? Yeah. Rotate the ellipse. Now, here's a struggle. Some of you guys are like, what? I don't remember conic sections. If you did remember conic sections, you could divide, just because I'm doing it in pre-cal right now. I'd probably remember anyway. But x squared over 4 plus y squared over 36 equals 1. This is going to be an ellipse with, let's see, horizontally to, that's my ellipse from pre-cal. Going right and left 2 from the HK of 0, 0. Going up and down 6 from the HK of 0, 0. Anyway, but this is the idea. Could you have gotten your calculator to do this for you? Yeah. Hey, can you hit apps? And then there's a menu called conics. If you hit apps on your calculator, oh, you guys have it. And then went to conics. You can technically, I think it's number 8. Is that right? Conics. They said ellipse. Go look at ellipse, number 2. Oh, hey, that's what the equation of an ellipse looks like. Because this one doesn't really help. But pause. You don't even have to do the conics one. Why? Because about this in terms of x or in terms of y. You have to think about this in terms of x or in terms of y. Let's think about that real quick. Have an ellipse. Maybe you guys realized HK was 0, 0. Maybe at least that came back. If that didn't come back, couldn't you have actually graphed this function by getting y by itself? And couldn't you have said that y is equal to the square root of 36 minus 9x squared? But careful, it's not just going to be 36, the positive square root of 36 minus 9x squared. It's also going to be the negative square root plus or minus square root. Actually, couldn't we just do alpha y equals and do the negative of y1? Huh, that's cool. And then if we did zoom standard, oh, that's not ellipse, there's a gap. Remember, calculators do pixels, and there's only so much it can go over before it's going to be wrong by going over anymore. I know it's kind of lame. Maybe some of you guys with the newer light-up screens, it might actually connect it because the programming is a little bit better. Does it connect it, Eric? Have you tried it? That's okay. No, it's okay, it's okay, it's okay, it's okay. So there's a gap, but it's an actual ellipse. No, we have the function. We see the ellipse. Okay, whatever, there he is. But we need to rotate him where or how? About the, ooh, does anybody remember the oblate?
Yeah, you know, vaguely.
It's the fan one.
She just looks ugly. I just remember that there's like
and it spins. Anyway, to think about that. C squared equals a squared b squared. Coming back. Shh. It's not. We're not doing. So dx is going to be, okay, so we need this in terms of y, right? Cool. So we have y equals, no. In terms of x. I said in terms of y. I apologize. I don't need plus or minus, and here's the reason why. Who's spinning? If I take the top, the positive square root, when I spin him, isn't he going to get the bottom part? So if I'm trying to think of radius of my circular cross section, my radius is going to be, so it's going to be a disk, not a washer. I need this to go ahead and flip around. And as it flips around, it'll get the bottom and get everything in between. What's my radius going to be? Why am I saying radius? This is a pi r squared. My bounds are going to be the far left, to the far right x. So I have -2 to 2. I need my radius. Radius is going to be top. Technically minus bottom. You put the minus dx. And Sean, that worked, yeah? I guess the new programming isn't that nice. Oh, good question. I don't know if you can find the zeros. We can try it real quick. Because Charlotte's wondering about the bounds, if she could have found the zeros. Because the problem is you can't go to the left and to the right because it's two separate functions. No, but what you could do is you could have done the, whether you hit the trace and do the shortcut, you could have tested and said, I think it's at -2. You could have tested it. And then you could have seen that there actually is a point even though it doesn't show. So you could have tested it. And they won't give you one that's like a nasty decimal. It's impossible to find a 0 using your calculator on these because it doesn't go through. And I doesn't go through. How can we guarantee a 0? Ooh, calculus in your calculator. Anything else? Number 2 on the FRQ? Or in the multiple choice? What are we doing? Multiple choice, David? Oh, I said number 2, sorry. Okay, FRQ number 1, we go to the answer key. Here he is. Guys, this is definitely a calculator problem in every way, shape, or form.
Oh, yeah.
So the very first thing before you do anything else, like, hey, just get your graph, get it set up, because you're going to probably need to use both of the functions, right? So I'm going to go ahead and throw in my e to the sine of x. I'm going to throw in my e to the x minus 1. Make sure, someone made this morning, make sure you don't put minus 1 up top. Make sure it's down bottom. It's outside of the e to the x, right? It was just a silly mistake someone made this morning. When they say, what is the region, area of the region R, which is bounded by f and g and y axis? Did you guys find the right one? F has to be one boundary, G has to be the other, and then the y-axis. Now hold on, this might be helpful to figure out who's who. Why do I know that this guy is G and this guy is F? It's e to the x down 1. This one's the e to the x. This one looks a lot more something trig. So, but I didn't know what this looks like, to be honest, without just kind of process of elimination. Pause. What's going to be really, 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 really important to use the whole FRQ? Why did they put it like that and use the little a? So you don't have to write it over and over and over and over. Like I think, wasn't it that did that on your actual mock AP? Yeah. Yeah. No, but now I write it once and use a little baby variable the whole time. It came up the other day. I forget why. You can use it over and over and over again. Can your calculator do this? Yes. That's just area between top minus bottom, but couldn't you have just done 1 minus the other absolute value just to be safe anyway? Then what's going on in letter B? What is the volume of the solid generated when R is revolved about the y-axis? About the y-axis. dx or dy? dy. It's about the y-axis. What's the struggle with dy? Oh, I read it wrong. It's x-axis. Thank you. dy would have been nasty. We would have had to get x by itself. There we go. dx, so I can steal it, just use it in terms of x. Is it flush? Remember, start at the axis and do what? Outermost, that's big R. Uh-oh, that's not a disk. That's a washer. So, the washer, we're going to have big R, that's our F. So we're going to have F minus 0 quantity squared and then G minus 0 quantity squared with the same A. Hey, right there. Plug them in your calculator, go. Plug them in your calculator, go. Letter C says, we're no longer spinning. What are we doing in letter C? Cross sections. So we're taking this guy and we're popping up out. Now question, perpendicular to what? Which means I'm going straight down, which means I'm doing dx, and I'm popping up in squares with a thickness of, I mean, you can pretend, there we go. What's the area formula for a square?
Side squared. Oh.
I can still use side squared. And what's the side? Top minus bottom. Dun, 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 dun. Plug it in and solve.
Do you have to do f of x minus g of x? Like, do you have to write f of x minus g of x, or can you just do lazy f minus g?
No, do f of x. Sorry, I was just being really quick. Kiddos, pass up number 10. Why? That way you can just focus on number 11, and then I'll have to grade it. Yay, I'll get to grade it. And I'll give it back to you guys tomorrow.
I actually, on the
Oh, he already passed it in. Thank you, Doza.
I just got lazy, so I didn't write it in the initial variable, and then I
Are some APs already ready?
Huh?
Are some already ready for APs?